Okay, hello everyone, and welcome to the Octant community meeting. This is our episode today on August 25, 2021. We are so glad that you are here. If you're joining us live or you're watching the recording, remember that you can add any topic you want to discuss in the agenda. The agenda is completely open. So there, for example, feel free to add your name and the organization you represent in the agenda. In case you don't have it and you're here, I will share it also in the Zoom chat. So let me start sharing my screen right there. Okay. There you go. Okay, so first of all, status updates. Well, we have a couple of GitHub projects which are created to collect, uh, work in two specific areas that we see important for Project Octant. First of all, is documentation. So we have a documentation project up there in the GitHub repo where we have added issues created in the past that are related to documentation. Documentation is it's an effort that on which we are trying to make progress and make it part of our release cadence. And if you have a documentation request, issue, etc., please feel free to create an issue and we'll add it here. It will be really useful for us to start prioritizing documentation efforts. There's a similar project that I call enablement because it's kind of more than documentation. It has to do with tutorials, demos, and some other use cases or some other training resources that I'm currently creating. I don't have much cards here, but the project is open, so feel free to add content there or create an issue and we'll add it here. So we can also have your feedback on what is more important for you in terms of training, enablement, and documentation. Right, so that's first. Then we have UI plugin management that is being moved out of .24. So I don't know if someone from the team wants to comment on that.
Yeah, just to capture the state of how our board of our current backlog, we did have an initial attempt to create a UI for plugin management, just simply because the way to do it currently is to go in the command line, and it doesn't make a whole lot of sense if you have this Electron application or a user interface, and all of a sudden you have to go to the command line or just start shuffling binaries around for your plugins. So we're bumping that out just simply because there is some complexity around it. And mainly it's the idea that normally you'd have to restart Octant in order to load a new plugin. And so there's some work to essentially make that process a bit more dynamic, or even just allow Octant to load that plugin without having a restart. So we could get the UI for it, but the actual implementation will be a little bit more involved. So it's going out of 0.24 currently just because we have some folks out. And so we'll just bump it out a few weeks.
Got it. Understand. Okay, any other comment, questions on this? Okay, I think we can move to the next item, WebSocket messages versus RPC calls. So
yeah, this one is also me again. So this, I will try to summarize this with it's linked to an issue that something bigger was working on. And essentially what's happening is that we're creating two mechanisms where a client can talk to the server whenever a user is trying to do something in Octant, and essentially there are two mechanisms. You can do RPC calls, which is essentially how the plugin mechanism works. If you kind of use like the dashboard client, you get all these exposed methods and you can do cluster operations. Or there's this concept of an action in Octant, which is essentially just a WebSocket message that gets passed around. And it seems to be that we don't have a good boundary on what these two are supposed to and not supposed to do. Initially, my thought process was that all of the RPC related calls are supposed to be done on cluster specific operations on the basis that we do want a very limited API surface so that a plugin doesn't potentially do nasty things. But then I've looked at our code a little bit and it turns out that's not true. We do have mechanisms for editing or changing a cluster state through the use of WebSocket messages. For example, here, apply YAML does do this, it doesn't use an RPC call currently, it uses a WebSocket message. And so because that's kind of blurred, we're hitting this weird point where we're sort of hitting duplication on both sides, and it's not very clear what should go where. And so this currently right now is going to be resolved by documentation, but I think we're going to need to have a proposal or some sort of convention or some guidance in the future on exactly what becomes an action and what becomes an RPC call. That's really all I have to say about this one. Vikram, do you have any other thoughts?
No, I mean, nothing to follow. Just, I've shared the same concern. Like, definitely we would need to come up with some kind of standard around which APIs you're going to expose for the plugins versus what we're supporting to WebSockets, and having a discussion around that would be great for the future.
Got it. Okay. Any other comments on this topic? I think it's really important. No? Okay. Okay. Thank you, Sam. Okay, yeah, next in the agenda is, well, I put it in the discussion points because we don't have a section on a special guest, but I think we should open one. We have a special guest in this meeting. It's my pleasure to introduce Daniel Pakak. He's open source software engineer in Aqua Security and one of the developers behind the Starboard plugin for Octant. So welcome to the meeting, Daniel.
Hi, everyone. Thanks, David, for introducing me, and thanks for having me.
Welcome.
Yeah, I think
so. Do you want to share your screen?
Yeah, I was thinking how to present this, in a little bit time constrained way. Yeah. So I didn't prepare a demo. I decided to go like a little bit of freestyle, but this will show you how am I using Octant for developing stuff. But also this will give you a like explanation why we developed Starboard, why we needed plugin, why we put some things on hold, and what are the things that we may want to add in the future if the plugins API allow it. So probably we won't have too much time for the discussion, but at least I think it'll be great for you to collect some feedback or like thoughts that I will try to share while presenting Starboard and installing the plugin. And actually, I will start. I wanted to have like a pre-created environment, and then I said, no, I will show you how I'm creating this. This will show you a missing pieces from my standpoint in Octant, and also some of the gotchas for plugin developers or installers or users. So hopefully this is gonna look interesting. And yes, I don't know how about the follow-up discussion, but let's try this out. I'm gonna share my screen.
Sure. Yeah, and thank you.
Sorry for my voice. I got cold this week. I decided to join anyways. So if my voice is a little bit shaky or that, sorry for that in advance.
Thank you, Daniel. I think it's 7 p.m. for you, right?
Yeah, plus it's a little bit late.
Thank you so much for doing this. Yeah, thank you so much for this extra effort. We really appreciate that.
Sure, no worries. So I need to tell you a little bit, you know, especially for those who watch this video online or offline, you know, what is Starboard? It's a very nautical name, a pretty cryptic, but I will show you this project, or you know, kind of a utility by installing it. And this is where, first of all, you have to go to Starboard documentation. We have an official documentation. You can navigate to it from the GitHub repository. And there are two installation modes. One is Starboard CLI, but more interesting and more useful is the operator. It's a Kubernetes operator pattern. Without going into much details, I'll just install it. And first of all, to make it useful, we need to install a couple of custom resource definitions. We use, or Starboard uses, custom resource definitions as data storage. It's not like in operators where you declare what kind of application or what kind of state you want to reconcile, but it's more like a data storage, like a config map with a schema. Think of it like that. And then we need to configure it, like a create service accounts, role-based access controls, objects. And as you can see, I'm using kubectl apply. There are different ways of doing this. There is a Helm installer, there is Open Lifecycle Manager, and we don't really support automated upgrades. But I'm doing this online to show you how painful it is and to share one of the items. Like I would do that all from the Octant interface, right? You see, I'm installing some objects, I'm installing some configuration objects, and you know, like manually inspecting it until the operator is installed. So like a first like a feedback or like a missing feature for me for some of the Kubernetes IDs nowadays, and in particular Octant, is the way to browse the catalog of Kubernetes artifacts. And I think Helm chart was one of the first ones. Then there is an operator lifecycle manager or OLM catalog. There are new ones, emerging ones. So it would be really cool to, you know, just click somewhere there, search for Starboard and install it. But even without this, it's already very useful, especially for, you know, navigating and making sure that what we did actually works. So this overview shows me the Starboard operator. It's up and running. I can go and see the pod. Usually you run this Kubernetes operator as a pod. So we could see and check logs, no scary errors. So it seems that it's working fine. So now a little bit more about what it does. So when we saw Octant for the first time, it was kind of an application, or at the time when I learned about it, it was a tool to show you what is running in the cluster, and especially show you things that are troublesome, like something is not working, something is broken, there is a missing label, or there is a typo in label selector. So this was like a great platform for us at Aqua, a security company, where we wanted to show some security threats. For example, show you that you're running a workload that is vulnerable, or show you, for example, a default configuration, or maybe a configuration which is not super secure from the operations or day two standpoint. And that's why we like those little icons. Green, it seems to be fine. Red indicates that something is wrong, etc. So I'll show you that by creating a deployment that we know will be vulnerable. So if I go ahead and create deployment, and I will use like a pretty old image reference. So what it does, you know, like we talk about like securing stuff, showing what is secure, what is insecure, shifting left, which is a common approach to shift the security responsibility to developers. But if you don't provide tools, or you will tell a developer that he has to go download some security scanner, scan his workload, and then check it back, most likely he won't do this. So that's why we wanted to base our integration on existing dashboards like Octant, where we don't have to develop UI, right? We are a security company. We don't want to spend most of our time in making, you know, UI beautiful. We just want to provide a security information. And this is, if you remember, I installed custom resource definitions in the cluster. And just a few seconds ago, I created a Nginx deployment in the default namespace. So if I switch here you will see that we have this Nginx, it's up and running. We have some default status information about number of replicas. We see that everything looks fine with the configuration of this object. But now we would like to see how it looks like from the security standpoint. And this is where we install the operator. And this operator is listening for such events as creating a new deployment, creating new replica set, creating new secret, and different kind of, basically we inspect different kind of Kubernetes resources, and then we inspect it asynchronously, and then we save the analysis in the custom resource instance. So now if I go ahead and list custom resources, you see that we have a config audit reports. This is where we store configuration auditing reports and vulnerability report. If I go here, you see that we have created a report for active replica set for the Nginx deployment, right? And this is a YAML file that contains all this information about vulnerabilities, like it inspects the container image, checks what packages are installed, and it is cross-checking the NVD databases or lots of other security advisories for the information. So this is pretty useful, but pretty ugly presented. I'm not saying about the default CRD viewer in Octant, which I think is great, but this information is not immediately available to the developers, right? Let's say I deployed Nginx, I see it's green, but what if it has some critical vulnerabilities? I want to show this information here. And this is where the Starboard Octant extension comes in, and I will go through the process of installing it. And I think I can pause here for a second. Do you have like immediate questions? If not, I'll continue. Okay, so let's take it.
Thank you.
Yeah, so let's take it further. So we have this project like a Starboard Octant plugin. Usually I'm looking for what other people's are doing. Do we have a competitors? Do we have followers? Do we have, I don't know, supporters? And unfortunately, there's not like a tons of plugins here, which is another interesting point for us to see if it's worth investing more into that. I can't do anything about this, but this is like kind of one of the metrics that we are looking at. Another one is a download kind. It seems that few people downloaded it already, but it's also not like a skyrocketing. If you look at the operator, we have like hundreds of thousands of downloads, which shows that people usually benefit from the installing the operator, but they don't really use the user interface, right? So it's kind of an indication. We didn't do like a study on that or like a heat maps or anything like this, but this basic metric showed me that if there is a bug in Octant plugin and there is a bug in the Starboard operator, I would probably go for the operator first. So if we want to install the plugin, this is at least my understanding when I first read about the documentation. It might have changed. So for that, and if the maintainers can catch this up and show me the other way of installing it, that would be great. But what I'm doing, since I'm running on macOS, I will download the release artifact. This is the Tor file. And basically we go to downloads and we have this binary. And now this binary contains the Starboard Octant executable, right? So it's a separate process. We have an Octant process running on my machine and we have the plugin process. So I guess they communicate through RPC, even though I remember there were lots of changes in this related to Electron and stuff. Honestly, I got lost. What is the current architecture of Octant? I didn't have time to catch up with this. So now if I copy this Starboard operator, and I'm supposed to copy it into config Octant plugins directory. There is this special directory where Octant picks up extensions. So let's do this and restart Octant. I have already installed Octant with Brew package manager on macOS. I think we don't have to repeat that. There's a great documentation about installing Octant on different platforms. And this is the first thing where macOS user can get scared off by installing plugins, right? This is by default. Our release process on GitHub is not signing the binary artifacts. So at this point, I think we can drop off quite a bunch of users. And the point is that macOS cannot validate this binary that we released as a for macOS, it's basically a malware or virus or whatever. So what I need to do is to go to the, how do I go there? Preferences. You see, this is live demo, not prepared in advance, but if I remember correctly, I need to go here into securities and enable it, like allow these extensions anyways, and try again. This time you'll see another pop-up where you can say, okay, confirm it. It's probably safe to run it. So this is another point. I told you about OLM or operator catalogs or Helm chart registry viewer browser, which can be developed as a native UI of Octant or maybe as a plugin. But essentially, we managed to install this plugin. It's visible here. We see that's the latest release. And now if we go and see our Nginx deployment, this looks the same, but there are new components, like a user interface components. It's not very visible because I didn't play too much with like a colorful extensions. And I think the built-in UI widgets are also limited in terms of customization, at least at the time when we first developed this extension. Or at least when I look at the documentation, this is what I could find. It's pretty easy to add or contribute to the status. And this is how, for example, we run, or to be more precise, the starboard operator detected that you created an Nginx deployment, that it is referring to the Nginx container image. So it ran the vulnerability scan in the background and it created a CRD. Now we are just taking the CRD. It is associated with this deployment through some naming convention or label selector. It's not important for the sake of talking about plugins, but eventually we can add this information, which is more like a human readable here, right? You don't have to read the YAML files. You see that this container image has critical vulnerabilities. I would love to add more warning icons and stuff like that, but you should get the point, like this is vulnerable. So now I could drill down. This is another contribution by the plugin where we see the list, right? So from this list, you can see what is this vulnerability all about? Is it any vendor fix provided? You can also navigate out of the plugin where we provide the description, some remediation steps, etc. So basically, this is already useful. What is still missing for me is, if you go back again here, it's hard to spot it. Then I haven't seen any mechanism to change the status of the icon based on the plugin, right? It is looking at the replica sets, or it is checking probably liveness probes, or checking the readiness checks, but it's not really, plugin cannot override the status, or it's not that easy. It would be really nice to mark it as red, that it's a let's say production workload. It has critical vulnerabilities. We should not show it as a successful. It's actually kind of a failure. Another thing that I wanted to add here was another tab. So here we talked about container image, right? Every application has to be containerized to run in Kubernetes. Another type of checks is to inspect the configuration descriptor. For example, do we run this workload as a root user? Do we drop some Linux capabilities, right? There's plenty of tools or plenty of blog posts that tell you don't run as root, right? In case your pod gets compromised, then you can use this for the privilege escalation, escape from the container to the host, and do other nasty things. So that's why we also generate another type of custom resource to hold the result of scanning the workload with configuration checker. By default in Starboard, it's Polaris by Fairwinds Ops, but it's also pluggable. You can write your own checks in OPA, which is another nice integration of all these tools that we are talking about today. But essentially, you see that this workload check is not running as host IPC. But some of them will, when the success is false, this basically shows that there is something to do for devs or DevOps to fix it. Again, if I go to workloads, Nginx, I have to search for it. Probably a lot of people will skip this section that is also contributed by the plugin. because at that time it wasn't possible to add a new tab. Right, but if you look carefully, you see this is another type of report. It's kind of a workaround, with all honesty. So I couldn't add it as a tab. So you see this is a metadata. It links back the report to the workload. You see some information about the scanner. This is a summary. And here we are. There's a simple representation of all the checks. It was pretty tricky to sort by different columns. I don't know if it was... there is this plugin, by the way, is written in Golang. I know there is a TypeScript APIs, but at the time was just Golang. So some of the components that we define or implement are kind of a representation of responses between plugin process and Octant main process. So some functionality is limited. Even adding the icons is somehow cumbersome. It's a mix of Golang with Markdown, with HTML, with some little nasty, well, not nasty, some little hacks, let's call it this way. But overall, it's useful. However, what I'm trying to say is that it should be easier. It should be easier for me to lay out these components, easily change this layout, change ideas. I had a feeling that once we put this in place, I don't want to touch this code or improve it because it wasn't that easy. And I think ordering by multiple columns would be very useful here. You see there is a severity and there is a category. And I would love to pop up this failing check to the top of the list. And also, I don't know what happened, if it's regression or it's just a layout. I couldn't jump easily to the next page, right? There are some checks. When I increase the page size, I see more warnings. So that's basically, from the functional standpoint, we also have another type of reports. This time, it's pretty nicely split here for the workloads like applications and infrastructure, which is, for example, nodes. So if I list nodes in Octant, we contributed another plugin. This one is running CIS benchmarks. Again, the starboard operator that we installed in the beginning discovered a node and run CIS benchmark. This is another tool, kubebench, basically starboard operator is so nice that it runs it on your behalf, right? So you don't have to switch back and forth. We can just focus on one user interface and see what is going on. For infrastructure engineers, this is useful. This will show you, especially for installation of Kubernetes on premises, because usually with managed clusters, there's nothing really you can do about it unless you contact the cloud provider. But if you are installing Kubernetes cluster on your own with kubeadm or other tools, it gives you a pretty interesting information, what can be fixed, how you can fix it, right? And this is like a textual or tabular representation of this summary. Still better than the YAML file, even though I believe that some interesting UI components like a pie chart or I don't know, something we can shake this UI or make it more appealing would be really cool for the Octant user interface. So yeah, I think from the functional standpoint, that's it. What I wanted to share and talk about today in terms of Starboard and plugins and how it looks like when you install it. And I think we can again stop here for a second if you want. And then the last part, I wanted to focus on the actual code and where I think it can be improved or where we actually bump into quite some issues when it comes to understanding the API and using it.
Thank you, Daniel. Yeah, I have a question so far, at least one. What did you find the easier, what was the easiest part during the plugin creation and what was the hardest task?
Yeah, so I think getting started based on the sample plugin that I found out in Octant GitHub space was easy. So it's very easy to get started, see your plugin registered there. However, when you start really doing useful stuff, like trying to get the data, trying to understand what is the life cycle of the plugin, this is where you do everything by experimenting. And it's not very easy to debug this process, right? This is an external process. So I know there are ways of doing this, but we are talking about like people like we want to integrate with other tools, but this is not our main focus. So debugging and trying to find out what will be the best UI component to render this part, or how I add multiple tabs, and then actually discovering hard way that it's not possible. That's, I think, was the biggest challenge. And the last one maybe is the client, Kubernetes client exposed to the Go plugins, which looked like a full-blown client that I can do everything with this plugin, but it's pretty limited. It's like a read-only, at least at the time of when we wrote this this version. And I didn't talk about that, but maybe let's wrap up this this question, and I can also talk about like a future plans and where we see other useful APIs for the plugins. Hopefully this answered the question. What was simple, what was
Yeah,
hard.
for sure. Thank you, Daniel. I don't know if anyone else from the team has a question or comment.
Yeah. So broad question is, would y'all still be open to taking PRs for some of these changes? I think like some of the concerns that you've mentioned, like for example, being able to change the color of the status icon based on the results of a security scan. I wrote some code that I guess like at the end of July that is merged in, and that allows you to do that. And same thing with a lot of the icons that have to be rendered in Markdown. Like I think those are simplified now. That being said, I don't know the state of this project and if it's still actively developed, and whether or not it's worthwhile to continue to move over to some of these simplified methods of doing these things.
Yeah, definitely. I think it's actively developed. Maybe we lost some traction because we bump into some like limitations of the APIs at that time. But any simplification will help. And I think this plugin is one of the biggest plugins out there. So even if it's not used as we intended it as a security tool to shift left security responsibility, this can be like a real, not sample up based plugin where you will show off or exercise all the APIs that you define. And I'm fully aware that this process is like incremental. So we would really appreciate any help, feedback, code review on this plugin, and for sure we'll reply to that. Yeah, I think some you are on mute, but hopefully this answered your question as well.
Yep. Thank you.
Yeah, so another thing, so if there are no more questions, I think we still have a few minutes to talk about code. I have this code open in IntelliJ. Sorry for that. I didn't look into that for quite some time, but hopefully I remember. One thing I wanted to show is, and I think I already mentioned this, like the API for me looks like representation of the data that is sent back and forth between the Octant process and the plugin. So for example, when I want to develop let's focus on this little tab, like let's say there is a workload of kind deployment or replica set or pod, and we want to add this vulnerability tabs, right? It doesn't make sense to add this tab for config maps. Config map doesn't really refer to any image, so we don't really do vulnerability scan of config maps, but we do config checks, right? For example, Starboard can check that you stored plain password, so it will warn you. So what I realized is that Octant is centric around GVK. GVK is this abbreviation for group version kind. Each and every Kubernetes resource has this kind of identifiers. However, so I would expect that when I do register extension points, I wouldn't talk about like a tab printers, etc., like print request, tab response, but I would more register it for a given GV keys. So what I'm trying to say is that it's fine, it's working, it's great because it is working. That's the most important one. But I think at scale, if your extension grows, you would like to define extension points or tabs based on the domain of Kubernetes, right? So I don't want to do this kind of a case switches, to render different tabs based on the Kubernetes object type, because this makes my component, like a custom component, huge, untestable, and overly complex. What I would like to do is to really understand what is the life cycle. And for example, when we register a tab response for a deployment, then I should have just a simple callback called, I don't know, on render. And then I know that, this is the place where I put my imperative code for, just drawing some tables or adding some status. So that's something that, as I mentioned, we started with Kubernetes workloads, so it's not that bad. We also have Node. If you remember, we do have tab for, let's go back to deployments and Jinx. Right, so for vulnerability reports, we don't add CIS benchmark tab. By the way, this wouldn't be possible because you can add only one tab for a given GVK. On the other hand, we add a different type of tab for nodes, right? So I think I can always do it this way, which is less readable. And I think for troubleshooting, for maintaining and scaling it up, it will be much better to, focus on GVKs and custom components. And a similar way, I think, is applicable to all types of extension points. Like for me, in the beginning, it was also pretty hard to understand, why is it limited to status field, right? What can I extend or put in the configuration? By the way, this is, even I forget, and now I reminded myself that here is where we add a summary for vulnerability reports. But if our configuration checker will detect some dangerous configs, it will add it here. Also pretty hidden in the great Octant user interface. So this is kind of like a main feedback for the Go code from the API standpoint. I think it's too centric on gRPC at that time communication protocol. And on the other hand, I wasn't pretty sure what is the status of this architecture. It used to be Go server. Then you started migrating to Electron. So I think it's like a hybrid now. And then at some point, I asked this question, what is the status of Go APIs and TypeScript APIs? And should we migrate or not? And I think it was like I wasn't confident, which way. Should we maintain this Go code? Or is it better to rewrite it in TypeScript? There are some good reasons why we use Go, because basically we use some of the utilities of Starboard. Starboard is an operator, Starboard is a CLI, but it's also a bunch of useful utilities that we have already written in Golang, so we can use it here. Otherwise, with TypeScript plugin, we'll have to rewrite some of this in JavaScript or TypeScript. So that's kind of a high-level overview. I don't want to sound like a criticizing this API. Again, I think it's great. These were just kind of the things that we found out during the development that you can take or leave. But hopefully this is useful.
Yeah, no, don't you worry, Daniel. The fact that you are here sharing your open feedback is really useful for the project.
Quick comment on the Go versus TypeScript distinction. So we did communicate at I guess some previous meetings that the intention is to maintain both, just simply because there are a lot of packages and imports within the Go space, and basically the Go ecosystem is Kubernetes. So it doesn't make a whole lot of sense to abandon that work, although it is more work on our part to maintain essentially essentially two different languages for the plugin interface.
Yeah, got it. I remember the discussion. Maybe that's my fault that I missed some of the community meetings. So I'm not blaming you for announcing it. It's basically probably my fault that I missed it. But again, sometimes maybe it's some information could be duplicated, so it's reaching out everyone. On the so the maybe the last thing I want to add here is what we want to do next. If you listen to what I presented here, you probably have realized that we're just showing this information. It's pretty useless, right? You showed me the critical vulnerabilities, and I don't know what to do with this. On the other hand, I can show you quickly the configuration of the starboard. It has plenty of configuration settings, mainly encoded in the config maps. I don't want people to edit YAML file or some key values going back to the documentation. We want to focus on one tab in the browser. Once you open Octant, you don't want to leave it. That's the goal. I know we are pretty far from this goal, but imagine this, right? I don't have to go out of this. I want to have a representation of config maps implemented as a plugin. I want to have nice drop downs, buttons to configure everything, to validate my configuration, preferably reusing some of the Go libraries or utilities that we already use. So this is like I'm talking about future now. So like a configuration, providing a user interface for configuring starboard, making sure there's another example I think more useful is this is generic starboard configuration. But if you look back at the vulnerability scanner, you saw that we are showing, let me go back here. Okay, I need to switch the namespace. By the way, selecting multiple namespaces, I don't know if it's possible, would be also useful. But if I go back here, you see that we show this report even though there is no fix. So there's one parameter. If I go back to to the starboard operator namespace, Trivi is the vulnerability scanner that we use. It's pluggable, so it doesn't really matter. But there is one flag actually where you can configure severity. And this is a one flag. It's not defaulted here that allows you to skip unfixed vulnerabilities, right? So you will see less vulnerabilities. But again, I don't want people to read the documentation. No one reads documentation. This should be self-explanatory. So I go to plugin. I click somewhere here like a configure starboard, or maybe we have like a top level view. I didn't talk about this top level view, but let's skip it for this time. And then maybe I should have some, UI, interesting UI components for editing stuff, not just for rendering stuff. And at the time when I played with the plugins API, there were not many components. There was the action kind of thing, which took me a long time to realize that it's kind of a button with input. But I believe it will be pretty useful to configure or edit config maps or secrets and do stuff like that for the plugin authors. And the last thing we were considering, and I think we put it on hold for different reasons, not because of plugins, API, or Octant. There are really many reasons for that. But I will share this. Imagine that I go back to the default namespace. We somehow move this config update report so everyone can see this. And then we also sort it up so this bubbles up to the top. And then we have a button here so I can say auto fix this. That would be great, because then imagine that behind the scenes we do patch the Nginx resource, right? Then Octant refreshes this refresh with the whole UI, and then ideally this warning or this danger should disappear. So that's kind of full experience, which wasn't easy to design and implement with the current APIs. And then, depending on the community or, downloads counts, we can think about other stuff. But the eventual goal, at least for us, was to make it useful, not just to display some data, but do something with this data. So, yeah, thanks again for, giving this opportunity to share the feedback. Take it easy. You do a great job. Yeah, hopefully we can help or work together or discuss things to make it even better.
Thank you so much, Daniel. Your feedback, as honest as it can be, it's really important for us. Our goal is to improve the project, to unlock some other use cases and extend what you can do with Starboard on Octant for sure. I had one question before I leave space for the team class. I can imagine that if you mentioned that it was easy to get started with examples, but the hardest part is to actually start putting data in the plugin, all of that. Probably you missed some documentation pieces, right? You wanted to have some particular documentation or tutorials probably would have been useful. So I don't know if you can in your mind collect the kind of documentation you would like to see for plugging outdoors. If you can mention here that, and or even better, if you could file an issue for that, it would be really useful for us because you have experienced the whole process, and probably you can say what's missing in the documentation.
Yeah, I think I can answer it in a bit different way. Forget about documentation. No one reads that. Not necessarily, but I remember when I was doing more front-end engineering, and every week there was a new JavaScript framework, and I think it still holds today. There was like a kitchen sink or widget kind of a type of a project that, for example, how to add tabs or pie charts in, I don't know, Angular.js or in React. Imagine that you have this kind of a kitchen sink. I don't remember if it's a kitchen sink it was a good name for this application, but imagine this like a show off all the components, UI components, tabs, extensions that you can do. And this is like a compiled language, right? It's not a documentation, which is hard to maintain. But if you build on top of this getting started or simple plugin, this can be really useful. At least that would be the first thing I would pick up, clone it, start messing up, commenting out some pieces, adding, duplicating code. So like a really nicely commented sample plugin, but not as simple as, just as, adding tab or maybe one button. Just add more of these widgets. Show more complicated use cases. This would be, at least for users like like more, maybe a little more advanced. That's something what we are looking for, right?
Yeah, that's
For
great.
for the original question and the documentation, I wouldn't be very useful because of what I said. I want to see the code. Show me the code,
For sure, yeah, that's great, especially because we already created an issue for that to create a kitchen sink plugin. So yeah, now with what you mentioned, I see the relevance of that. Great, thank you, Daniel. I don't know
Yeah.
if
And just to add on that, sort of for like, I took it as a kind of a brainstorming, and also like it recalls me what I was thought about these plugins. I also mentioned that there's no plugin for I don't know to which extent you are familiar with OLM, like operator lifecycle manager. This is an operator for managing operators. It's basically very cool, like for day two operations, for installing stuff, monitoring stuff, auto upgrades. But the learning path is very steep. It's based on CRDs. That there's a plenty of CRDs that are created. They have to, hop from one state to the other until your operator is installed. And I think for me, this is kind of a great candidate for a plugin. It can be core plugin or plugin maintained by Octant maintainers. This is something similar to kitchen sink. I think the complexity of this is even like a more complex than kitchen sink, where you show off all the widgets. This is really useful thing that shows how to use the dynamic client. You will quickly identify what are the gaps in this client. Maybe you will miss some, functionality for modifying Kubernetes objects. For now, I think it's great for reading stuff, and sometimes it's limiting. But with a real world plugins, or maybe refactoring or extracting some of the core functionality of Octant to the plugin ecosystem. Basically, when you run Octant, this will be loaded automatically. This can open some of the opportunities to drive this API. Otherwise, I think we get stuck with a simple plugins, and we may miss some of the interesting use cases that are possible.
That's amazing. Thanks so much, Daniel. I think I will need to rewatch this recording several times to take notes. Thank you. I don't know if anyone else from the team, Wayne, Felipe, Bikram, Sam, have any additional comment, questions?
Yeah, nothing in particular. I just want to thank Daniel for taking the time out of your evening to give this feedback to us. It's extremely helpful, just from a developer's perspective, as well as just letting us know that like what we can do better. And thank you for your honesty as well. And I think like ultimately, that's how we all improve and lift the whole ecosystem as a whole.
Sure, no problem. And thanks again for giving me the opportunity to share the feedback. If I was using Octant in some very weird or peculiar way, and there's an easy way, or you saw some crazy code, please let us know. You know, we are also learning. And I know that things are changing and we don't always have time to catch up. So I really appreciate you listening to us, and keep up doing great job.
Awesome. Thank you, Daniel. Well, if there is no additional comment or question from the team, well, I will wrap up the meeting. Thank you, Daniel. Thank you for everyone for joining. And again, we'll keep working to improve the project to make all your use cases even better. So thank you so much for being here. Goodbye.